Welcome, 8th graders. Sorry this is a bit late. All right. Today we talk about rates of chemical reactions. Activation energy. That's what we need to start a reaction. We talked about the matches. That activation energy is that friction which gets that going. Well, why do we need that? It's the minimum amount of energy to start a chemical reaction. You have to have this energy. Why? Because this energy breaks the old bonds so new ones can be started. Just like this Lego example. I have this wonderful, beautiful house that my daughter and I built together. We get tired of it, we don't want it anymore, but those are all the Legos I have. So, I have to break down those Legos so that we can construct a new home. Alright? The activation energy is just like that. It breaks down those old bonds, so you have individual atoms, and then those atoms can reconfigure in new ways. Reaction rate. Now, this is how fast a reaction occurs. How fast reactant is consumed, or how fast the product is created. It's kind of like a glass half full, or is it glass half empty type thing. With that, either way is a good way to look at it. How fast is a reactant consumed? That's the stuff before the reaction happens. How fast is the product created? Well, that's the stuff that becomes after the chemical reaction. So what things affect reaction rate? Now with reaction rate, temperature, concentration of the liquid, and surface area. So temperature, what the hotness or coldness, the amount of surface area that's there, and we'll talk about that in a bit, and how concentrated the item is. All of those things affect how fast the reaction occurs. Here's the temperature's effect. Hotter temperatures speed up reactions because particles move faster. Remember how with solids we got hotter, particles are moving faster. With gases, they move the fastest. When particles are moving faster, they're more likely to run into each other, and those reactions can happen. However, colder temperatures slow down reactions because the particles move slower. When they move slower, there's a less likelihood of those collisions happening. That being said, why would we refrigerate food then? Colder temperatures slow down the chemical reaction of food spoiling. Therefore, they keep longer in these colder temperatures. Concentration, and we're not talking, we're really going to think about it. No. More concentrated, the reaction happens faster because more collisions of particles. If there's more things there, there's more things to run into. Less concentrated, the reaction happens slower because there's less chance of collisions of particles. If we have just this little bit here, they're going to be bouncing around in this area. There's not a big chance of collisions happening and reactions happening. If we have more, they're more concentrated, there's a better chance that those collisions will happen. Now, concentration of are two things that are important. When would our reactants, the stuff before the chemical reaction, be the most concentrated? And when would our products be the most concentrated? Which one goes where? Reactants are most concentrated before the reaction because they're all there. Products are most concentrated after the reaction has taken place because they're all there. Now, surface area affects reactions. Now, when you look here at this surface area, there's 8 cubes that build that big cube. Here, there's 8 small cubes. 1, 2, 3, 4, 5, 6, 7, 8. Well, each cube has a surface for that to hook onto. But when we look, each of these cubes has 6 surfaces showing. So for every 3 surfaces, they can have 1 circle. Now we can have nearly twice the number of things attached to those cubes. So this, just the outside is there, so we can only have 2, 4, 6, 8 of them attached. Over there, there's more surfaces, so more of them can attach. Think about it like a big ice cube. A big ice cube in a cup of water lasts a long time because only that outside is there. If you crush that down and make it into a bunch of little ice cubes, you put that in the water, those little ice cubes will quickly dissolve because there's more surface area for that water to touch it on and make that reaction happen faster, although that's a physical reaction. More surface area. Reaction happens faster when there's more area to react on. Or the opposite, less surface area. Reaction happens slower when there's less area to react on. Those are two ways to put it. And that picture kind of illustrates it. Or think about this example. These logs are the same size. Which one would burn faster? Why? Well, it's not going to be this one. It can only touch the flame on the end and all around. This one, you've got that whole outer surface area, plus when you split it, you create all this new surface area that'll be exposed to the flame, and these will burn faster. So more surface area allows for more speed of the reaction. Slowing down reactions. We can do this with things called inhibitors. It's a chemical that slows down or stops the reaction. Examples of these are butylated hydroxytoluene, BHT. Things like Jell-O and processed cereals have it. Processed mixes. They're not so good for your health, some people will say, but the jury's still out on that. But that's an example of an inhibitor we use to help things keep from spoiling. Inhibitors to rust would be keep the metal dry or paint it. In both of these situations, painting it and keeping it dry will not allow rust to happen as quickly. It inhibits that process because you need oxygen, metal, and water or moisture. If you paint it, that inhibits it by not letting moisture get there. If you keep it in a dry location, that inhibits it by not letting moisture get there. So, inhibitors to metal rusting would be those items. Now, speeding up reactions. Catalyst, the exact opposite of inhibitors. They're just one or the other. Speed it up. How? Some provide a surface for the reaction. Others reduce the activation energy needed. So they make it easier for the stuff to happen. They give it a place to happen, or they take away the amount of energy that it needs to happen. If there's less energy, it's easier to do. It's a lot easier to ride a bike a mile than to run a mile. So that bike is kind of like my catalyst. Oh, it provides less energy to do that same trip. I'm going to ride the bike. Catalytic converters has catalysts. Have catalyst. All right. Sorry about the grammar. I'm the science and math guy, not English. What happens inside of them? There are catalysts in there that help turn the carbon monoxide that cars create into water and carbon dioxide, which is more friendly to our environment. So that's an example of a catalyst being used in our real life. Now enzymes, they are something special. They are the large protein molecules that speed up reactions. Those reactions happen to be in our body. So enzymes are the catalysts of our body. They help the body do all these things: convert food to energy, build bone and muscle, convert extra energy to fat so you can store it for later on, and produce other enzymes. And the digestive ones, we'll just look at them. They provide a place to grab onto it, split it. Now they turn it into glucose and fructose, which the body can use more readily and more easily. Enzymes, the catalysts of our body. All right, guys and gals, your favorite screen's here. See ya.